Section 7.3 deals with what are called polyatomic ions and the transitional metal ions. So last time I kind of just didn't talk about those. So we will now. All right. So this is these are once again still ionic bonds between a metal and a nonmetal. All right, so polyatomic ions. So what are those? So polyatomic ions are just ions made of more than one element, and they're super common. In fact, we've used a lot of them. Sulfate, we've used a lot of copper sulfate in the lab. We used, let's see, what else have we used in the lab? Well, sodium bicarbonate, that's one of them. So they're very common, and they're around us all over. And one of them is the ammonium ion. We talked about that too. So ammonium makes an ion. It has right here, has a positive one charge. And what it actually looks like is this over here, okay? So it's one nitrogen that's actually bonded to four different hydrogens, okay? Now, this is actually, if you look at it, those are covalent bonds. Those are different. We haven't talked about those yet, but it's okay. You don't need to know that. All you need to know is that this is a polyatomic ion, NH4 positive 1. And this is the only positive polyatomic ion that we will talk about. All right, the next one down here is a hydroxide. Well, we've used that too. So sodium hydroxide is Li. And this is actually oxygen bonded, and here it is right here. This is a picture of it. Oxygen bonded to one hydrogen, and it has a -1 charge. All right, most of the ones we're going to talk about have a negative charge. All right, and when I give these to you, I'm going to give them to you in a big chart like this. So you do not need to memorize these, don't worry. But you do need to recognize when they're used, okay? So here's our ammonium ion we were talking about before. It has a +1 charge. You can see it's the only positive one. Here's our hydroxide with our -1. Another thing I want to point out is the sulfate and sulfite. Those are really common. So sulfuric acid, which is a hydrogen sulfate technically, is battery acid. So sulfate right here has this structure. It's SO4 and it has a -2 charge. Sulfite is different. All right, you can see that it's just the A or the I. It has one less oxygen, but it still has the same charge. Interestingly, it still has a -2 charge. So. Yeah, so those are the two different things. There's also nitrate. We might see these too, nitrate and nitrite. Those are really common. Phosphate is right here, also is very common. Potassium, or not potassium, yeah, potassium phosphates in gunpowder. All right, so these are some examples of polyatomic ions in ionic compounds. So the first one is sodium and carbonate. Okay, so when we do these, we still follow the same process as before. So the first thing you want to do is write down your ions, your cation, or the positive one first, right? Na. So oh yeah, I did. All right, Na is over here, so it's going to make a +1 charge. Now, the carbonate, nicely, they tell us what the charge is, all right? So you don't even have to figure it out, okay? Now, what we do, let's go ahead. We're going to crisscross again. So let me change the color of my pen. All right, let's crisscross the numbers here. We still need to make sure we have a neutral compound. So that means there's going to be 2 sodium and 1 what is called the carbonate. So the way we would write this then is Na2CO3. All right. Now notice once again, there's no charge. There is no charge in that compound. All right, let's do the next one. So magnesium, let's look at our periodic table for magnesium. All right, come on. Oh, now it's not wanting to switch. Okay, all right, so magnesium, all right, remember, if you guys remember, it has a +2 charge. You can look at the periodic table. Phosphate right here has a -3 charge. All right, so this is going to be one of those cases where you have the 2 and the 3. All right, so I'm going to change my pen color briefly. All right, so the 2 is going to go down here at the end now. The 3 goes over here. Now, now, what do we do when we have 2 of here? Now, if we just wrote it here, PO4, 2, it would look like we had 42 oxygen, which is not what we want, right? We want 2 of this actual whole thing. And that 4 should never change. So what we're going to do is we're going to write it. So Mg, there's going to be 3 of those. All right, now there's 2 of the potassium. So what we do is we put it in parentheses. All right, and we could put the PO4, don't change the 4 at all, and we put the 2 on the outside. All right, so that's the correct way to write the polyatomic ions. when there is more than one. So if there is more than one, write this down, use parentheses. All right. Okay, and we never want to change that 4. Like this 3 in carbonate will never change, and the 4 in potassium will never change. Always just leave those just as they are. All right, so let's move on. There we go. Okay, so transitional metals now. So that's polyatomic ions. So transitional metals. Transitional metals are groups 3 through 12, technically. Actually, that should be 12. 13 is boron, all right? So the transitional metals are the ones all in the middle here, right? And they have, if you remember, they have a d orbital is the very last orbital that's filled for their electron configuration. So it's really hard to predict the type of ion they will make. And actually, a lot of them will make more than one type. So you cannot tell just by where they are on the periodic table. So what they do is they tell you with Roman numerals right here, the charge of the ions. So Fe2, the Roman numeral, just II is 2. That tells you that the iron right here has a charge of positive 2. Remember, they're all going to be positive because they're negative. They're metals. We can have Fe3 also. And that means that the iron will have a charge of positive 3. It has different states depending on things. All right, and the next one is manganese. And if you remember, we'll talk about this though. IV means 4. It means 1. So manganese has a positive 4 charge. So they tell you what the charge will be with the Roman numerals. All right, so if we look at the Roman numerals, if you guys remember, just to review, just I is +1, or +1, +2 is 2 lines there, 3 lines is +3, and this one is +4. And we really won't talk about much more than that because it's not very common to have ions that have a charge larger than +4. Okay, so let's do some examples. So we still, when we were predicting the compound, the chemical formula for our ionic compound, we still follow the same procedure, all right? So go ahead and write the charge of our ions first. So we know iron here is telling us the 3 there is telling us that the charge is +3. Chlorine, if we look over here, chlorine's right here. It's going to have a charge of -1 because it's a halogen, all right? Now we're going to go ahead and flip our numbers. The 3 is going to go down here. The 1's going to go over here. So there's 1 iron and there's 3 chlorine in our compound. That's iron chloride. All right, let's do one more example. So chromium and fluorine. So fluorine is just like, it's just right above chlorine there. It's still going to have the -1 charge. So our chromium right here, the 2 is telling us it has a +2 charge. And our fluorine is telling us that we have a -1 charge. So if we do our little switching maneuver, right, that means that there's 1 chromium for 2 fluorine. Okay. All right, so next I want you guys to practice these. There's a mixture of things here now. So now you'll need to recognize whether it's just a regular element you can predict from the periodic table, right? If it's a transitional metal or if it is a polyatomic. So go ahead and practice this on your own and we'll review them in class.